Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Zuhdi and Razali. So now I'm gonna do my presentation on self-assembly. This is basically my own opinion and understanding, and also I would like to add some research on my behalf about self-assembly relatable with bio-nanotechnology. Thank you. So first and foremost, a little bit about myself. I am actually a 23 years old student, and my height is 5 feet and 5 inches. I was born in Terengganu, Malaysia, but were raised in Gombak, Selangor, also in Malaysia. If you would like to know me a little bit more, you can follow my Instagram, Zuhdi Razali. Thank you. Now we will start with our main objective, which is what does self-assembly means. So basically, self-assembly is a process in which a disordered system of pre-existing components form an organized structure. It is also based on a driven force that are applied to the material itself. In other words, self-assembly is the aggregation of particles in an organized structure that have no involvement of external assistance such as human, pressure, and also other cases. This is the consequences of a specific component and the local interactions among the components themselves. So fundamentally, there are five common driven forces that are usually used in self-assembly. The first one is heat, the second one is surface tension, or also known as surface energy. The third one is hydrophobicity of the material, and the fourth one is the meniscus capillary reaction, and lastly, which is the chemical interactions. Basically, those five driven forces have their own mechanism in producing force for the self-assembled. So now we will proceed to our second objective, which is how can we relate self-assembly with bio-nanotechnology. In my case, I'll be using molecular paint and carpet peptides. These peptides can actually self-assembly and also form a monolayer on top of a layer there are actually few nanometers thick on the surface. So this can enhance the attachment of cells, and also they can trap other molecules and thereby producing molecular recognitions. There are actually three important segments in our molecular carpet peptides. These peptides are widely used for the cell-cell interactions and also behavior. There are actually three important segmental features in the structure. The first one is the ligand segment, which is also considered as the head function to the cell-specific recognition by the molecules or cells. The second one is the central linker, which acts as the body of the structure, which then provide a rigid and flexibility property. The third one, which is the last one, is the tail, which is called surface anchor. This is actually the interaction between the particular surface material with which the peptide that are sticking to the surface of the particle. Thus it immobilizes the peptide. Now we proceed to the self-assembled monolayer, a molecular layer that are assembled on the surface by using adsorption. This is usually used by a solution. It mediates by the specific functional group that has a strong affinity towards the particular surface. One molecular layer of the material that bonded to the surface in order away as a result of a physical or chemical forces during the position process. It is influenced by numerous factors that includes the nature, the texture of the substrate, its hydrophobicity, surface tension, and many more. The self-assembly is one of the important strategies in biology for the development of a complex and also functional structure. So now I will share one of my research study. In this research study, I am using laminin-derived peptide in order to affect the keratinocyte activity. This is for the usage of the dental implant in order to prevent peri-implantitis. The peptides are immobilized on top of the surface biomedical devices. This involves two processes, which is physical and also chemical routes in order to do the peptide coating. I am using laminin, which is for the purpose of cell adhesions. Promoting peptide immobilized by using two methods, which is silanization and also copper-free click chemistry. LEMLG3 is the name of the product, and in this study we used two coater, which is by using click chemistry DLEMLG3 and also silanization SLEMLG3, and the result shown that DLEMLG3 showed a promising result which can capable of upregulate amidosmosome formation a little bit more than other coater. So this LAM-LG3 capable of inducing hemidosmosome formation for the oral keratinocytes in the soft tissue that are surrounding the dental implant. So now we proceed to the procedure of testing LAM-LG3. We are using mass spectrometry and HPLC, which is to synthesize the peptide. And we also use X-ray photoelectron spectroscopy, which is to access the surface elemental composition. And we use borosilicate glass discs that were activated by the plasma cleaning in order to expose the reactive hydroxyl myostatin. And DLEM, LG3 and SLM LG3 were incubated at 37 degrees Celsius in an artificial saliva for up to 70 days to assess their simulated intraoral durability. So now we proceed to the methodology of printing peptide. We are using micro-contact printing by using laminin peptide and also ethylene glycol thiolate. PDMS is also used, which is one of the most employed material in to mold microfluid devices. PDMS is first oxidized using O2 plasma ink with a 2 millimole ethanol solution of ethylene glycol thiolate and then dried under the steam of nitrogen. The ink stamp was placed on a gold substrate for approximately 1 minute and then peeled off carefully. The gold substrate was immersed in 2 millimole aqueous solution of laminin for 2 hours, removed, rinsed with deionized and distilled water as well as ethanol, and lastly dried under the steam of nitrogen. Now we proceed to the benefit of the research. The benefit of the research is actually to prevent a disease called peri-implantitis and also to upregulate the hemidosmosome, as you can see in the picture before. And we also want to promote the oral keratinocyte viability and also proliferation, as well as to improve cell-cell interaction and spreading. And lastly, for our future prospect, we wish that the cell adhesion peptide activities are vastly explored in the future, and thus will increase the high rate of having a healthy peri-implant in dental sector, as well as in the future, this discovery can fully be utilized in other fields of medical devices such as the major organ implants. With that, I end my presentation, but before that, I would like to thank everyone for listening and spending your time. So if you guys have any problem or inquiry, you can contact me through email, mobile phone, and also my website. Thank you so much.